next topic is fractions and standard form. So we'll be talking about fractions more than the standard form in this chapter. And later we will move on to standard forms. So what type of fractions do we have? Let's discuss a little about them. For example, we have like 1 by 3, that could be a fraction. 7 by 4 could be a fraction. Do you see any difference between them?
Yes. For 1 by 3, the denominator is larger than the numerator.
Very
So,
good.
and then the next one, the numerator is larger than the denominator. So the other one would be an improper fraction.
Very good. So improper fraction could be written as mixed number. So 1 whole 3 by 4. Okay, so let's talk about these. Okay, fractions and standard form, we'll talk about them when we face a question. That is just the writing style. A quick recap, equivalent fractions. So we all know that if we are talking about these two, 1 by 2 and 4 by 2. So if I just simplify this 4 by 8, that is 4 1 times, 4 2 times. So again 1 by 2, they are equivalent fractions. If the question says that you are given with like 3 by 5, this is the prime question. An examiner says write down 4 equivalent fractions. So may I write 3 by 5 as 6 by 10? What else could I write?
Well, you can write about 15 by 25.
Numerator 15, denominator 25. Yes. Make me write 4 of these. 2 are done.
And then 18 by 30.
18 by 30. Very good. You're multiplying both numbers with same number.
And then 12 by 20.
12 by 20. Very good. So these were equivalent fractions. Mixed number, we just talked about it. 3 whole 4 by 7 is a mixed number. And calculating the fraction, I was just sending the distraction away. Okay, mixed numbers, convert between mixed numbers and improper fractions. So when we have the fraction, we can always change it into mixed number and the mixed number back. So if I have like this A and B over C, so what I can do is multiply A with C plus B over C. In numerical form, that would be easy to understand. For example, if we have 7 whole 1 by 3, so 3 7 times is 21. 21 plus 1 is 22, so 22 by 3. So from mixed number to improper fraction or from improper fraction to mixed number. Calculations with fractions, we know that we have to follow the mass rule where it is division, multiplication, addition, subtraction. My personal preference is I always change this division into multiplication first and then I just deal with them. I deal with positive and negative ones at the same time. It makes no difference. For example, I have 1 minus 2 plus 3. So I don't have to go for addition first. So we can do it like subtraction first. For example, 1 minus 2 is minus 1 plus 3. So my final answer is positive 2.
There's
One
also
thing,
for division and multiplication, right? You can do
yeah,
both ways, right?
yes, we can do both. Answer will be correct. But there are some forms I'll share with you shortly. I'll share with you. To avoid like careless mistake, it is advised to change them into multiplication first and then simplify. Or else what we could do is we always solve from left to right. For example, let's take a light example. 16 divided by 8 divided by 4 divided by 2. So what we can do is either we do it 16. I have this division sign, right? So I'm writing it 1 over 8. Then I have this next division sign again. So I'm writing 1 by 4. This division sign, I'm writing 1 by 2. So when we solve these, I know 8 2 times is 16, 8 1 times, 8 2 times, 2 goes with this 2, and I'm left with 1 by 4. One way. Or the other, if we do not change it, we write 16 divided by 8 divided by 4 divided by 2. Now we solve it from left to right. So 16 by 8 is 2 divided by 4 divided by 2. Now 2 divided by 4 is 1 by 2, or may I write 0.5 for ease? So 0.5 divided by 2. This will leave me with 0.25 or 1 by 4. If we move from left to right, just try it doing some other way. 16 divided by 8 divided by 4 divided by 2. Give it a try. We've just discussed them with two methods. I'll show that again.
Mm, So you turn it into multiplication.
Yeah, that is one way. We can
Uh,
change it to multiplication, or we can only solve it from left to right. Other than that, we will get a wrong answer. Either change to multiplication or left to right.
yeah. Yeah, I got the
Or
same
else, or
question.
else we'll get a wrong answer. For example, if I solve these two first, this is 16 divided by 2 divided by 2, right? I've changed the order. This will give me wrong answer. Now 16 by 2 is 8 and 8 by 2 is 4. And what were we getting? 1 by 4 for both of them. But it is always fine with positive and negative. You can change their order. But do not forget that this negative sign was with which given number.
Yeah.
For example, 1 minus 2 plus 3. So now the mass rule tells me to do addition first. So if I go for addition, I should look at this sign. This is 1 minus 2 and plus 3 is plus 1. I'm getting plus 1. But if I violate this rule and go for subtraction first, that is 1 minus 2 is minus 1, and then addition, I'm getting 2 on both sides. It works fine with positive and negative, and it works fine when all of them are multiplying with each other. So equivalent fraction, we just work with them. Either we multiply them both numerator and denominator with 2, with 3, or with 4. Whatever the demand of the question is, as many fractions, we can write them. Now, these are the worked example. Which of the two are the equivalent fractions? If I just look at these two, first is 5 by 6, the other is 15 by 18, and 20 by 25. So how will we get to it? We just have to simplify. I cannot simplify 5 by 6 more than this. So 3 5 times, 3 6 times is 5 by 6. And the last one, if we see this is 5 4 times, this is 5 5 times, that is 4 by 5. So we can clearly see the first two are equivalent fractions, third one is different. This chapter particularly will not involve increasing or decreasing order, but these fractions or equivalent fractions are going to help us a lot when we face those questions. Arrange them in ascending or descending order. For example, if I'm given with 1 by 5, 1 by 6, 3 by 5, 3 by 4, I might have to think for few seconds. But when I have like 1 by 5, 2 by 5, 3 by 5, 7 by 5, I don't need to think because all the denominators are same. So when we are strong in equivalent fractions or converting fractions into proper, improper, or something else, we could definitely work that out. For example, if I have 1 by 3 and 2 by 9, I may have to think for few seconds which one is larger and which one is smaller. But what if I multiply these two with 3 and write 3 by 9 and 2 by 9? Now, at a glance, I know which one was the larger number. So this will help us there. Okay, exercise 5.1 shows by multiplying or dividing. Let me get into it more. By multiplying or dividing both numerator and denominator by the same number, just like we did in the example earlier, and find three equivalent fractions. So let's do this first one, that is 5 by 9. So if
So
we just multiply both with 2,
10,
always choose 10 and 18. Always choose a smaller number whenever you have that option.
15
And
by 27,
that's right.
20,
Uh,
36.
20 by 36. Very good. Now it says express each of the following fractions in its simplest form. So first part, what would the answer be?
3/7.
That's 3 over 7. Okay, now there are 1 by 3.
Oh, sorry?
There should be 1 by 3.
Yeah, because you divide the 7 by the 2, yeah.
I'll show you those questions. Now, this was something which was one step answer.
Mhm.
Like there was no working for it. There are questions, you'll face them, I'll show you. For example, I know your mental math is very good. For example, this is 2x plus 1 and 3x plus 2. I know you can do it without writing on paper. Just let me know the answer without writing.
2x plus 2 and then plus 3x plus 6. And then
So,
simple
yeah, simplified form, final answer.
5x plus 3.
5x plus
3? No. 5x plus 8.
8. I think this was the mistake in the test, or you would have scored 100 on 100. Because we had interactive classes, but the examiner who's going to check your Cambridge exam won't know who the student is. Okay? With the passage of time, I may know your weaknesses as well. Till now, you've performed very good. Stay that way. But you will have instructions on the first page of your paper that omission of essential working will result in loss of marks. Now, no one has ever explained what is essential. So, what do we do? What we're thinking, we just have to write that on paper. You must have thought 2x plus 2 and 3x plus 6. You just have to write it on paper. Now, 3 and 2 is 5x plus 8. Now, what actually happens? Suppose I've made a mistake in the last step, but I will be scored till here because that's correct. And what if I directly write the answer and that is not correct? I'll lose all the marks.
And it's also
So,
good if I can check it from before and see like
yes,
when you can match it up. Yeah.
yes. So, you can always give a feedback like the length of test, the time of test, the marks of test. We can always interact with each other and work step by step, increasing our strength in terms of achieving full marks and in lesser time. Obviously, if I give the same test to you and ask you to complete it in 15 minutes, that would be unfair. So you at least have to think about it. Writing time may be reduced, but a student must be given its thinking time. So next time I'll try to even reduce the questions, and whatever you'll share with me, try that working steps are there. Okay, if this is not for me, this is not for you. This is to make the habit to follow the rules for the examination paper pattern. Okay. So, and understanding that what this multiplication actually means. Some students are confused if it is being multiplied with 5 or with 7 or with both. It is always with the numerator unless until something is above it. For example, if 5 by 7 into 1 by 3, then it is 5 by 21. When it is the only number, that is always with the numerator. Okay, 2 5 times is 10, 3 9 times is 27. There was no cancellation. There was no number which went into the same table. Look at C part.
8 by 36.
That's good. Let me write this. 1 by 4 times 8 by 9. Now, this is 1 8 times 8, 4 9 times 36. It is correct. Can we simplify it further?
You can simplify it into 2 by 9.
2 by 9. So what if I just write that again, and before multiplying, if I just cancel them at the initial stage, I have to think a little less because the numbers are small. 8 by 36 is a larger number, that is very much correct. But these small numbers are easy to handle. Now look at this question number D. If I just multiply the 7 and 16, that would be a large number. But what if I do 7 one times and 7 two times? And before multiplying 2 one time and 2 eight time. Now what am I left with? 2 one time, 2 four time. This is 1 by 4. Let me bring that out again and make it more tidy. This is 2 by 7 times 14 by 16. Now if I just solve it this way, 7 one times and 7 two times is 14. Changing colors just to show where am I cancelling these. 2 one times and 2 eight times is 16. And the last one, 2 one time and 2 four times. So in numerator, I am left with 1 into 1 and denominator 1 into 4. In other ways, it would have been 14 two times is 28 and 16 7 times 7 6 are 42, 7 8 9 10 11. It would be 112. And again, we'll cancel it to get 114. Now I cannot recall 7 times something. I already know that it goes with 7 because I've simplified it first. But what can I do? I can use 2. So with 2, this is 14. This is half of 112, which is 56. Now 14 by 56. Again with 2 is 7 by 28. Now I know 7 one time, 7 four times. We always get the same answer, but it depends on our practice, how we've led things through. For example, look at this 2a. Let me copy it down to have more writing space. Question 2a says 50 by 128 times 256 by 500. Now, if I multiply these two, I'll be getting very large numbers. May I do it 50 one times and 50 10 times?
Mhm.
On the other side, this is 128 one time and 2 times. Now, let me share how I actually realized that this is 2 times. I had a habit, once I was studying computer, I had this habit of calculation 2, and I kept on doubling it. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. And if you realize, these are also the memories of your RAM or your hard drive. You have 1024 MBs in 1 GB and so on. I forgot what is the next unit. I think that's a TB. So 1 TB is equal to 1024 of GBs. So that's how I quickly did that. That 128 is two times is 256.
So one
Or
over
else,
answer for that one, right? 1/5.
yeah, 1/5, yes. So that's 2 by 10 and 1 by 5. You can still cancel it over there, like 2 1 times 2 5 times and write that directly. Now this cutting on the paper. If you're sending me this answer, I would know that is correct, but I won't know how you managed to get here. And if there's a mistake, I won't know. And if I have your workings as well, I would know where are you doing these cancellations and where the mistake might be. Now, if this question scores 1 in total, it has to be perfect all the way to get this mark. If it scores 2 in total, yes, we can still get 1 out of 2 for the correct working and wrong answer. Once we have both these things, correct working and correct answer, we'll obviously score full mark. Okay. Now all of these are like the same type, but practice. Try question number 2E and 2F. E and F.
Question E is 4, I think. And
Uh, E part is 4. How?
well, it was I turned a mixed number into an improper fraction, so it was 4/3 times
4 by
24
3.
over 1. And then I
Yeah, 4 by 3 times 24.
yeah, and then 24 I simplified it by 3, which got me 1 and then 8 on the 24 side. And then I simplified the 8 by the 4, which got me 1 and then 4 over on the 8.
Okay. Okay. I thought you were giving the final answer. So this is 4 by 3. That's very good. That's very good. 32. And the F part.
Okay.
Do you want me to zoom in?
No, I'm good. $319/2.
Over 8.
I simplified the 2 and the 4 as well. 1 and then 2.
First
We,
number is 11 by 2. Do we agree?
yeah. Oh, you can only simplify diagonally, right?
Yeah, the diagonals. You can
Okay.
cancel them, the diagonals, or if they are on the opposite side of the equation.
Okay. Diag
Example, we have 3 by 7 times 1 by 9. This is 3 1 times, 3 3 times, and the final answer is 1 by 21. This was the diagonal. Second option, 1 by 7 into 3 by 9. So we have 3 1 time and 3 3 times. Again 1 by 21. It is basically one in numerator, the other in denominator. And last thing, like if we have suppose x by 9 is equals to 4 by 27. Now we can cancel this 9 and 27. They are in opposite side of the equation. 9 1 times 9 3 times. So x is equals to 4 by 3. Let me do this again. This last thing. See that we had x by 9 is equals to 4 by 27. Now, if I have to find x, I'm going to multiply 9 on the other side and it becomes 4 by 27 into 9. And that is 9 1 times and 9 3 times. So we again get 4 by 3. This 9 in any way would have gone there and been in the numerator and we cancel it with the denominator. Other than that, one has to be in the numerator, the other has to be in the denominator. Clear?
Mhm.
Okay. Adding and subtracting. I think we've been through these while we were discussing LCM. So this would be quick. We already have 1 by 2 plus 1 by 4. This is a traditional method of making the denominator same. This is for those students who are unable to find the LCM and do them directly. But I think we can do it, right?
Mhm.
We know that LCM of 2 and 4 is 4. Now 4 divided by 2 is 2. 2 into 1 is 2. 4 divided by 4 is 1. 1 into 1 is 1. So we get 3 by 4. We get the same answer. Other methods, cross multiplying. This was 1 by 2 and 1 by 4. 1 by 2 plus 1 by 4. First method from the book, we're making the denominator same. So we are multiplying this with 2 and getting 2 by 4 plus 1 by 4. Once we have the denominator same, we can add the numerators and get 3 by 4. One thing, we are doing the same thing, but the process is different. LCM is 4. 4 divided by 2 is 2. This is just 2. And we are multiplying it with 1. Again, this is the same 2. So 2 plus 1 is 3 by 4. Last method. Now, if I write 1 by 2 plus 1 by 4, if you want to proceed through cross multiplication, you have to do this first arrow, then the second arrow, and then the last arrow, third one. Can you understand these three arrows? If I'm multiplying this green arrow, I'll be writing 4 1 times 4. I'm multiplying this blue arrow, I'm writing 4, 2 into 1 is 2. And multiplying the denominators, that is 4 2 times 8. I'm getting 6 by 8. And then we cancel these two. 3 2 times, 2 3 times, and 2 4 times, getting 3 by 4. So we have all 3 by 4, whichever method we choose to do so. Okay, let's okay. Write these directly without working.
2/3.
Try B part,
5 7. 5/7.
C part.
2/8. So 1/4.
Very good.
13 by 9.
Very good. Okay. Now one could ask what this evaluate means. Do I have to leave it here or I should write this? Both are correct unless until specified. Questions sometimes tell you that leave your answer as mixed number. So when it is not specified, both are correct. Okay. try G part.
7/8.
I'll do it quickly. Very good. 7/8. Whatever the method is. During class, we may try them with different methods, and in exam, there is no compulsion. Okay. Question number 2A. Let me use this space. Now we know question is 4 minus 2 by 3, and we already know how to take LCM. So we know that this is 4 by 1 minus 2 by 3. Either cross multiplication or LCM or making the denominator same. All three methods are correct. Done. I'm just trying with different methods. Okay. Let's try this bit longer question. K part. Are we getting the same answer?
Mhm.
And let's try to go for mixed number. 11 is smaller than 12. So that can't be 1. Moving on. 12 into 10 is 120. 12 into 9 is 108. 3. That is 9 whole 3 by 12. Do you know we can simplify these 3 1 times, 3 4 times, and write 9 whole 1 by 4?
Because it's in the same one.
And after writing this, I just realized we could have cancelled it with 3 as well. For example, 113 with 3. 3 times is 9. 3 1 times. No, it's not divided by 113. So that's 9 whole 1 by 4 or 9 whole 3 by 12. Okay. Dividing fractions. Again, same. We will be going for reciprocals. 3 by dividing fractions. 3 by 4 divided by 1 by 2. So we first reciprocate it and change it into multiplication. Now that is the same as we discussed earlier. 3 1 times is 3, 2 1 times is 2. And it is our choice unless specified. Either we write it like 1 whole 1 by 2 or 3 by 2 or 1.5. This is our choice. Okay. Dividing fractions. Try question 9A. What are you getting?
I'm doing the simplification part.
Oh, okay.
Seven over 10 like you.
Very good. Okay, handling the decimal. To remove the decimal, like in the first 1A option, I have to multiply the numerator by 10, and so would be doing in the denominator. So it is 1 by 30 clearly. So let me write few numbers and you let me know the answers. If I write 0.1 by 4, it will be equal to 140. Okay. So in this way. So if I have 0.1 by 5, what will be the answer?
1 by 50.
1 by 50. If I write 0.2 by 5, what will be the answer?
2 by 50.
2 by 50 and then
1 by 25.
very good. If we have 0.03 divided by 4,
3 by 400.
very good. So you know how to deal with these decimals. And let's try it one more time in the other way. 0.07. So it would be
4 by, no, 400 by 7.
400 by 7. So we have to do it both in numerator and denominator. And what if we have decimals in both the sides? For example, 0.5 by 0.03.
50 by 3.
Very good. So you also know what is the deciding factor. Either we choose 10 or we choose 100. So we choose the larger number. Very good. Okay. Try question number 5.
360 over 15.
360 by 15. Yes. And then we simplify.
Mm, 24. Yeah.
Did you do it directly?
Directly? No, I did 15 divided by 360, like that.
Oh, the long division thing. Like this?
Yeah.
Okay. I'll just share. So you should have multiple methods in your mind. I had this 360 and 15. First, I thought of 10 to eliminate the 0. Then I thought that it would be 1.5. It will get difficult for me. Then I saw, yes, 3 times is 5 and 312 times is 36 and this 0 goes back. Now, when I have 120 over 5, it was easy for me to think of equivalent fractions and eliminate these two and write 24. Now, I never did this on paper. I did that mentally and wrote to 120 by 5 is 24. But there is something, if you see this working, there is something on paper and that is compulsory. Try question number 7. It is your choice. You may choose any method. There's no restriction in exam. Do we have the same answer?
Mhm.
Okay. Now I would like to do this again without removing the decimals. For example, this was 0.4 into 1.5 by 1.6. We can clearly see that zero point 0.4 is 4 times 1.6 because we can visualize this is 4 times 16. So you can also do this. This is 1. This is 4. Now I can write 15 by 40. 5 with 3 times, 5 8 times. So it is never a compulsion that you have to remove decimals first. But whatever you're doing should be on paper. The examiner must be able to see which mark you took. Okay. Same thing, but in statements. 3 by 4 of the people at an auction, 3 by 4 of the people at an auction bought an item. If there are 120 people at the auction, how many bought something?
One over 160 because it's 3/4 divided by 120.
And how many people bought something?
How many people bought something? Oh, so subtracting. Yeah, subtracting the two.
And what are we getting?
90?
90. Basically, 3 by 4 of 120 is the 3 by 4 of 120. 4 1 times, 4 30 times, and 3 into 30 is 90. Question 2 said an essay contains 420 sentences. 80 of these sentences contain typing errors. What fraction, given in its simplest form, of these sentences contain errors? So we have errors in 80 out of 420, and now we simplify.
4 over 21. Yeah, 4 over
4.
20.
Question 3. I think these questions are much better than those fractions. 28 is 2 by 7 of which number?
98?
98, correct. If 3 by 5 of the people in a theater buy a snack during the interval, and of those who buy a snack, 5 by 7 buy ice cream. Of those, what fraction of people in the theater buy ice cream?
3 over 7.
Let me quickly solve it. 3 by 5 of people in a theater buy a snack during the interval. And of those who buy the snack, 5 by 7, what fraction of people in it? Okay, so whatever, how many people they are, we don't know. So this is 3 by 5 of the total. And then out of those 5 by 7. So yes, 3 by 7. Very good. Fifth says Andrew, Bashir, and Candy are trying to save money for a birthday party. If Andrew saves 1 by 4 of the total needed, Bashir saves 2 by 5, and Candy saves 1 by 10. What fraction of the cost of the party is left to pay? Just give me a second, I'll close the door.
Twenty-four?
It
No,
should be a fraction.
yeah, it should be.
Meanwhile, I'll extract this data. And a machine can you are trying to save money for a birthday party. If Andrew saves 1 by 4, Andrew is saving 1 by 4. Bashir saves 2 by 5, and Candy saves 1 by 10. What fraction is left? What fraction of the cost of the party is left to be? Yeah, it should be a fraction.
One fourth.
1/4, yes. Next one. Joseph needs 6 1 by 2 cups of cooked rice for a recipe of nasi Georgian. If 2 cups of uncooked rice with 2.5 cup of water make 4 1 by 3 cup of cooked rice, how many cup of uncooked rice does Joseph need for this recipe? How much water should he add? Okay, that would be unitary method. Do you want me to start with you?
Mm, I can try it, and then if I need help, then yeah.
Okay. Should I interrupt?
Sorry?
Should I interrupt?
Yeah.
Okay. Now, first of all, whatever I'm going to say is my personal opinion about this question. Whenever I have these type of statements, either I lack practice or either this is not my first language. So I feel comfortable when I break these questions into parts. Joseph needs a 6 whole 1/2 cups of cooked rice for a recipe. This is my first part. Okay, this is what Joseph needs. If 2 cups of uncooked rice with 2.5 cup of water make this of cooked rice. So I'm looking at this two and this 4 1/3 that two of uncooked are giving me 4 whole 1/3 of cooked. I've done nothing. I've just extracted the information. I've left behind 6 1/2. I've left behind 2 1/2 because I'm looking at uncooked rice and I'm looking what I'm actually getting out of it. My target is 6 1/2. So I should use X uncooked rice to get 6 1/2. Now I was actually extracting data and I was talking to you, so I've never changed them, or else I would have just wrote 6.5 in this place. Now what am I going to do? I'm going to cross multiply to find X. So 2 into, may I write 6.5 or 13/2 on the other side? 13/3 into X. So now I'm going to simplify 2 1 times, 2 1 times again. And I can see that I can simplify this 13 as well. Even in the next step, I would be dividing it. It still has to go out and 3 on the other side, X is equals to 3. Now I know if I use 3 cups of uncooked rice, I will get 6 whole 1/2 of cooked rice. Does it make sense?
Yes.
So uncooked should be 3 cups. One part done. Now for the water part. Uncooked, cooked. We are using 2 whole 1/2 cup of water, 2 whole 1/2 to reach 6 1/2. Now we are talking about water. So we should use Y amount of water. Sorry. Uh, We are using 2 1/2 to reach 4 1/3. So we should use Y to reach 6 1/2 and again cross multiply. So this would be 2 2s are 4 1 5/2 into 13/2. On the other side, 13/3 into Y. I'm simplifying. 13 goes with 13. This is 15/4. So Y is equals to 15/4. Gives me 4 3 times is 12. 13, 14, 15.
Oh, I think you made a mistake. It's not supposed to be 4, it's supposed to be 2. When you were writing it, I wrote it
We're
as
done
4.
with we're done with rice right here. Now I'm dealing with water part.
Yeah, I mean, like when you were doing the mixed number into an improper fraction, you accidentally wrote it as 4.
Oh, thank you. Thank you so much. Yes. So this is 15/2. That is 7.5 or 7 whole 1/2. So how much water should he add? That is 7 1/2. How many cups of uncooked rice? So that was 3. So uncooked rice is 3. And how much water? That is 7 1/2. Percentages. Now, whatever we do with the fractions, whatever our requirement is, the profit, the loss, or anything, or fraction of the height, we just multiply it with 100 to get percentages. For example, we score 7 out of 10 on a test. What percentage have we scored? We just multiplied with 100, and that is 70%. So if we have a number 1.2, I'm changing it into percentage, that will be 120%. So we simply multiplied with 100. And from percentages to fractions, we divide it with 100. Okay, the percentage is a fraction of denominator with 100 and a percentage sign. So 40% of 25. 40% of 25 would mean 40 by 100 of 25. 1 times, 4 times, 10. So 10 out of 25 is the 40%. Equivalent forms again, like the cancellation simplification. Suppose we are talking about 45%. So I can write 45 by 100, or I can write 5 9 times and 5 20 times. So I can write 9 by 20 of anything would be 45%. Let's move to the exercise part. Okay, 5.7. Convert each of the following percentages into fractions in its simplest form. So the first one is 70%. That would be 70 by 100.
7/10.
That is 7 over 10. B part,
75/100. So simplify with 5. 5. 13/20.
that should not be 13.
Hmm.
75, if we go with 5, that's 15.
15/20. So then we can simplify it further to give us 3/4.
Okay. Now, if we see at 75 by 100 next time, we are going to try to eliminate it with 25.
Oh, yeah.
25 3 times, 25 4 times. Okay, so let's try these with decimals. K part, 2.25.
Yeah, so 1/40.
1 over 400.
Yeah, 1/400.
Okay, now just evaluate yourself. Look at my working. Like if it is out of 2 marks, be neutral. Will the examiner grade it 1 out of 2? Because for sure, if we have written 1 by 40, that is incorrect. But do we have the working that we can at least score 1?
Yes.
So make that a habit, okay? To be on safer side. And I'll share those documents soon where we are explained that we have to show the working. Number 2, express the following fractions as percentages. So all we have to do is multiply with 100%. 5 1 times 5 20. 20 into 3 is 60%. 3 by 5 into 100. Simplification is 60%. B part into 100, what will it be?
28%.
7 4 times is 28%. Correct. Into 100, what will it be?
85%,
Very good.
30%.
I like 30%. And this right here,
4%.
4%. Last one.
And equals to 25.
What are we getting?
It's with a decimal, so 41 point, um, sorry, my pencil.
So we could either write it as 125 by 3%, or we can change it into decimals.
Yeah.
That is 41.6.
Yeah.
When I got this second two again, this was my first two, this was the second two. I realized at that point that this will keep on continuing, so I stopped. We also call it reoccurring decimal or reoccurring number, recurring decimal. So we can denote it with this dot as well. Okay, finding one number as percentage of the of another, which we just discussed. Suppose we scored 8 out of 10. That is 8 as a percentage of 10. And when we convert it, we get 80%. So express 16 as a percentage of 48. 16 is numerator, 48 is denominator, and times 100. And then we simplify. 8 2 times, 8 6 times is 48. 2 1 time, 2 3 times. So 100 by 3, 33.3%. And let's have a look at the exercise. Where appropriate, give your answer to 3 significant figures. Now, this is how the examiner will be giving you instructions in the exam. To express 14 as a percentage of 35. 14 by 35 into 100. 5 7 times. 5 20 times. Then we can go for 7 and 14. 7 1 time. 7 2 times, and 2 into 20 is 40%. Try question 2.
25%?
25 is correct, but why did we take so long? If I just see 3.5 by 14 into 100, one way is we remove this decimal. Just do with me. 3.5 plus 3.5 will give me
Sorry?
3.5 plus 3.5 will give me
7?
7. And 7 plus 7 will give me
14?
14. So that is straight away 1 time and 4 time. And 4 1 times, 4 25 times. Okay, question number 3. Express 17 as a percentage of 63. I'm actually looking for decimal numbers. So 17 by 63 into 100. Now this may be the time. Yes, it is. So we know 17 by 63 into 100. They do not go in any other table. 63 is odd number, 100 is even number, and 17 is a prime number. So that is 1700 by 63. So 63 1 times is nothing. 2 times is 126. 3 times is 189. So I'm going for 2 times. Okay, so this is 1, 2, 3, 4, 5, 6 times because 7th time it went over that. So 6 times is 378. So 10 minus 8 is 2. 13, 7 is 6. So 62. And we may need to add one decimal. And 620. I'm trying with, if I try with 10, that would be 630. And coming back, 1 times 63 would be easier. 2, 10, 3, 7. 12 and 6 is 3, 576. So 9 times is 576. Already got 3 decimal place, 3 significant numbers. So 226.9%. Okay, I think for today, uh, we won't be considering very long homework. Do you have a provision to take screenshot?
I'm
Is it possible on
recording.
your side?
Sorry?
Is that possible for you to take a screenshot?
Yeah, it is.
So I would like you to take the screenshot and try these remaining questions for
Okay.
today. And once we complete them, then I'll share a proper homework.
Okay, I got it.
Anything you would like to ask?
Um, no, I don't think so.
And what are we studying at school regarding mathematics?
Right now we're doing constructions, like we're learning how to draw like triangles, circles, and like inside
Right.
of it.
Geometry and constructions. Okay, very good. Okay, see you tomorrow then.
Okay, thank you.
Take care. You will come here yesterday.
Mhm.
Did you get time to solve these four?
Yes.
Okay, 36 people live in a block of flats. 28 of these people jog around the park each morning. What percentage of people live in the block of flats who jogging? 28 by 36 times 100. First answer is 77.7 for question 4.
Okay.
Did we get the same answer?
Sorry.
77.7%. And fifth one says Jack scores 19 by 20 in test. What percent of marks did Jack get? 19 by 24 times 100 is 79.2 rounded. 79.2.
Mm, I got 79.1, but it's
That,
okay, right? If I got it?
yeah, that's
Okay.
okay. Okay. It was 79.16, so on. So I just rounded it to three significant figures.
Okay.
Question says express 1.3 as a percentage of 5.2. That's 25% exact. And the last one is express this as a percentage of 520. So 0.13 divided by 520 times 100 is 0.025%. Okay. So next topic is percentage increase and decrease. So for example, we talk about salary. And if one is giving the best performance as desired, so he should expect an increase in the salary that might be percentage, that might be a bonus, that might be a fixed price. So percentage increase is always on a set value, and percentage decrease is also on that fixed value. We can like discuss that. Let's say there's a product that is in a sale. So 10% sale would mean 10% decrease in price. So we have to pay the remaining 90%. So percentage increase and decrease. Work the example says the value of house increases from 120,000 to 124,800 between August and December. What percentage increase is this? So first we find the difference between these two, which is 4,800. And this 4,800, we are considering the base value as 120. So 4,800 divided by 120 into 100. You never have to get confused between which value to choose, either 120,000 or 124,800, because it was an increase on this price. So that becomes your denominator. Where appropriate, give your answer to the nearest whole percent. Over 5 years period, the population of state of Louisiana in United States of America decreased from this to this. Find the percentage decrease. First, I'm going to find the difference. Now, difference is 4468976 minus 4287768. I'm using calculator. And I'm getting a difference of 181,208. 181,208. Now, this is the decrease on this first value. So to find percentage decrease, we will divide the difference with this first value, 181,208 by 448,976 times 100. Because if we change the denominator, entire percentage would change. This is 4468 times 100 is 4.05%. Question number 2 says Sunil bought 38 CDs 1 year and 46 the next year. Find the percentage increase. How will we do this?
So you first find the difference.
Okay.
So 46 and 38. And then you would find the percentage of it.
A difference divided by which value?
Divided by 38. Because it's
38.
increasing like that value.
It is increasing by that value. So 8 divided by 38 times 100 gives me 400 by 19, which is 21.05, approximately equal to 21.1%. Now, the same question with the different method. For example, we do not find the difference and we directly divide 46 by 38 times 100. So 46 divided by 38 times 100 is giving me 121.1. Is it pretty explanatory itself? Whatever is on top of 100, that is the percentage increase.
Oh.
So even if we make a mistake in exam, we should always know what we are required to answer. Find the percentage increase. So this could be method A and method B. So once we do this, what are we going to do later is find the difference. So 121.1 minus 100, finally we'll be answering 21.1% increase. So either we find the difference in start or at the end. Answer is same. How's the construction exercise going at school?
It's going good. We finished it. So the next unit, I'm gonna see what is going to be next week.
Okay. And what were the main shapes? Triangles, quadrilaterals?
Triangles, hexagons, octagons, and then we also learned how to draw like perpendicular lines, and we also learned about the Pythagorean theorem.
Good.
That's basically.
That's all. Question 3. A theater has enough seats for 450 audience members. After renovation, it is expected that this number will increase to 480. Find the percentage increase.
So you first find the difference and then times it by 100 after you divide them.
Dividing with which number?
450.
450. So whatever is the first number, either it is decreasing or increasing. Whatever was there, whatever was existing first is our base consideration. And this is 6.7%. Most of these questions are like from calculator exercise. Question number 4 says Sally works in an electrical component factory. On Monday, she makes a total of 363 components, but on Tuesday, she makes 432. Calculate the percentage increase. Theme is again same. 432 minus 363 and I'm getting 69. So difference divided by the original value times 100. Gives me 19%. I was getting 9.008, so I wrote 19. Both of these are again of the same nature. Let's try some different questions. Increasing and decreasing by a given percentage. So in these questions, we were given with values and we found the percentage. In this case, we are given with the percentage and we are going to tell them that number. So increase 56 by 10%. Now there are again two ways. One is right in front of you is finding 10% of 56. 56 times 10 by 100 because we need to increase 10% and it is 5.6. So what happens? 56 plus 5.6 gives me 61.6. That is one way. What could be the other way? If we are increasing it by 10%, may I say the final amount would be 100 plus 10 is equal to 110%.
Yes.
So 56 times 110 by 100 directly gives me 61.6. So both are correct and interchangeable. Now let's discuss if we are talking about a decrease. Let me consider a few easy values so we don't need calculator all the time. For example, there is a product that costs $100, $1,000, and we want to buy it, and we know that the prices will come down and by 20%. And I know 20% of it will be 200. So the remaining price will be 800. Now there are two ways. Either we find 20% of it first. 0 goes with 0. This 0 goes with this 0. 100 into 2 is 200. So this is the decrease, 20% decrease. And the remaining price is 1000 minus 200 is equals to 800. Or we can say if 20% is decreasing, we are actually going to pay 80% of the remaining. If 20% is decreasing, we are actually paying 80% of it. Or let's say the shopkeeper says you're getting a 20% discount. So we are going to pay 80% of whatever was marked. So 0 goes with this 0, second 0 goes with this. Now 100 into 8 is 800. So whatever we do, we'll end up with the same answer. This was decrease. When we talk about increase, let's say the product was for $1,000 and we are expecting 10% increase. Again, two ways. Either I find the 10% first 0, second 0, that is 100. So 10% increase will lead us to 1000 plus 100, that is $1,100. Or the second way could be the product was for $1,000. When 10% increase is there, now this is the full price, which is actually the 100% price. So if it is increasing by 10%, it should become 110%. So 110% of 1000, 110 by 100 into 1000. Dealing with these zeros, first goes away, second goes away. Now 11 into 100 is $1,100. So we get the same answer. The summary is when we are talking about the decrease, the numerator is less than 100. When we are talking about increase, 10% increase, the numerator is more than 100. So if I say the product price is X, or let's say that should be cost price. The cost price is X, and let's make it more simple. Let's get the shopkeeper out of it. Selling price, whatever the selling price is X. So if it increases by 20%, I'll be writing 120 over 100. Rather than going through these two steps, like X plus 20% of X, they're exactly the same. They're exactly the same. And when I know that it is decreasing by 6%, it is decreasing by 6%, so I'll have to pay 94 of the remaining rather than writing X minus 6% of X. Method A, method B. We did few questions, but we did all of them with method B. So percentage is increasing, we can write directly more than 100 in numerator. Percentage is decreasing, we can write the remaining in the numerator. I'll simplify this for you. Let's say this is 1. I know x by 100 minus 6x by 100. Taking the LCM or multiplying these two with 100, I get 100x by 100 minus 6x by 100. Now, may I combine these? When I do so, this is 100x minus 6x by 100. What do we get in the numerator? 100 minus
94.
94. 94 x by 100. So what do we have here? 94x by 100. So whenever it is increasing, it has to be more than 100. Whenever it is decreasing, it has to be less than 100. So again, if the product costs $25 and we are expecting an increase of 12%, so what will be the new price? It will be 25 into 112 over 100. 12% increase. This will be the new price.
The 100 with the 12.
Yeah. And if the product was for $35 and we're expecting a decrease of 11%, so new price will be 35 times 89 by 100. We're actually paying the remaining 89%. We don't have to do it in two steps, like finding the 11% first, then subtracting it from 35. We can directly find the remaining 89%. Now, what actually happens when we walk around this store? We are there for shopping, and it is written on different stalls that this section is like 20% off, this section is 30% off. So in my mind, what am I doing? 20% off. So I'm calculating the remaining 80%. I'm actually multiplying every price with 0.8 and telling my mother or father, this will cost us this, this will cost us this. So if there is 30% off, I'm multiplying the remaining amount on the sticker with 0.7.
Okay.
And whenever there's an increase in real life, that never happens that they would mention that it was, they never do that, that it was 4.39 and now it is 5.13. They never do that. But whenever they decrease the price, they do show you that it was 4.39 and they mark this cross and say now 3.12. So that's a marketing strategy for now. Calculating percentage is our task. Okay. Now it says increase 40. This is our number under consideration. Increase 40 by 10%. So may I multiply 40 by 110 over 100?
Yes.
This is 44. And increase 40 by 15% is 40 into 115 over 100. Makes it 46%. Try question number C and D. That would be easy to solve without calculator.
$50? What? Yeah,
Correct.
50
That's correct.
for D, and for D, just 2?
5% is 2 plus 40. So new is 42. When we
42.
increase 40 by 5%, that is 42. And whatever we've discussed, do we understand that this is a personal preference? In exam, there's no restriction. Either you find the number first and then add, or you do it directly. There's no restriction. Question number 2. It says increase 53 by these given percentages. So let's try these last two. What does this 112 mean? Simply, if I say the price is $25, so when I increase it by 100%, will it become 50?
Mhm.
Increasing it by 100% would mean 200 by 100 into 25. So we're actually doubling it. Here in my country, we have taxes on imported cars. If we import a sports car, the tax may range up to 300%. That would mean if the cost of the car is 100, it will be 400 in this country after a tax of 300%. So this is the price plus 300% of tax will actually make it 4 times expensive. Is the math clear or should I repeat it? That what
Mhm.
plus 300 means? Original price is always there and 300% would mean add 3 times of it. So 4x is the final price.
Yeah.
Now this 112 increase 153 by 112% will mean we are looking at a number which will be 212%. So either we do 53 into 112 over 100 plus 53, or we do 53 into 212 over 100. Both should give us same answer.
59.30. 6 plus 53.
I've used calculator and these are the two
No.
options. Try E part. Are you doing it manually or do you have a
Yeah.
calculator?
Should I get a calculator? I was doing it manually.
Yeah, do get it.
Okay.
E part.
53.265.
Correct. Okay. Now same thing, but in reverse order. We were adding them. Now we are subtracting these. So 124 by 10%.
One hundred 111.6.
111.6, yes. So either this method or when we are decreasing it by 10% would mean 90% of it remains. So 10 less than 100 is 90 will give us this answer. Either we subtract it later or we subtract it in the first step. Final answer is same. Try this part. They're actually solving it.
18.1.
D part.
18. Yeah, 18.1.
When we decrease it by 100%, if I say
Zero.
here 0,
Okay.
so 100% of it goes down. That is 0. 18.1 would be when you decrease it by 50%.
Zero.
Applying your skills. Whenever you go out, remember this topic and do try to apply. That would just enable you to have a feel that is my answer correct? You'll get a feel of it. Like 36.5, half should be 18.1, that should be 50%. 100% is going, that should be a 0. That happens with us sometimes when we are solving a paper, we don't know the answer, but we have a feel that I'm going in the right direction. So try to see things around you and apply mathematics wherever you can. This will make the subject very easy and logical and interesting. Okay. Shaji, you usually works 30 hours per week, but decides that he needs to increase this by 10%. To be sure, I'm just looking at this 10% and multiplying in my mind. Okay, 10% is 3, so he should be working 33 hours. He's increasing by 10%. To be sure, he can save enough for holiday. How many hours per week will Shaji need to work? So I'm doing 30 into 110 over 100. I like these zeros. They're very easy to cancel. And 11 into 3 is 33. So he needs to work 33 hours a week. Question 6. 12% sales tax is applied to all items of clothing sold in a certain shop. Okay, 12% sale tax. If a t-shirt is advertised for $12 before tax, what will be the cost? Gee, what should we do?
Divided by 13, 13.44. Because it's just 112 times
Correct.
112 times 12 divided by 100.
Correct. 13.44. That would cost $13.44. Question 7. The Eyelet Theatre steps up its advertising campaign and manages to increase its audience by 23% during the year. If 21,300 people watched play at the Eyelet Theatre during previous year, how many people watched play in the year of the campaign?
Mm-hmm. 26,199. Yeah.
The population of Trigwell was 153,000 at the end of year. Following a flood, 17% of the residents of Trigwell moved away. What was the population of Trigwell after the flood?
126,990.
Correct. 126,990. Ninth question. Anthea decides that she's watching too much television. If Anthea watched 12 hours of the television in 1 week and then decreased this by 12% to next week, how much time did Anthea spend watching television in the second week? Give your answer in hours and minutes.
Ten hours and 56 minutes.
Okay, this is when you solve this, 12 into 88 by 100, or the other way around, the answer is 10.56. But we have to convert it into hours and minutes. These are 10.56 hours all the way. These are not minutes. So it is 10 hours complete, and the remaining is 0.56 times 60. So we have 60 minutes and 1 hour. So 0.56 into 60 is giving me
3.6.
33.6, approximately equal to 34. So my answer would be 10 hours and 34 minutes. Reverse percentage. Till now, whatever we are doing, we are discussing that product is for $1,000 and it will be 20% less. The product is for $1,000 and it will be 10% more. Now, what are we moving forward to? You are given with the new price and we have to find what it was. Till now, we've done what it will be. Now we'll find what it was. For example, let me say in 2008, price is $600 and I'm giving you it is a decrease of 25% of the price in 2007. What was the price in 2007? Can you try that?
$450.
The price in 2007.
Okay, so 1,050.
No. Are the wordings of question clear? In 2008, price is 600. It is a decrease of 25% of the price in 2007. Whatever the price was, that price decreased by 25% and now the price is 600. Our prime focus is not 600. The mistake is you're finding the 25% of 600. Till now, whatever we've discussed, we've focused on the denominator, right? What would be the denominator? Change divided by the original. Change divided by the original. Either it is increase or decrease. Our prime focus is the unknown price in 2007 because this 25% is applicable on that unknown price. Whatever that price was, We decreased that price by 25% and made it 600, right?
Mm-hmm.
Or we can say whatever the price was, remaining 75% of it is 600. These are two ways. I'll write more ways, whatever makes you comfortable. So this is x is equals to 600 into 100 divided by 75 gives me 800. Now we have all the numbers. 800 was in 2007. Reduce 800 by 25% will give you 600. But when you find 25% of 600, that is 150. 25% of 800 is 200. So these are two ways of just writing this. Final answer is the same. And there's one more way we can write it. I would personally suggest you to choose one of these. And there's one addition which is perfectly fine for examination, but during practice, we can select any method, right? So it was like this that 2007 and 2008. In 2007, it was X. In 2008, it was 600. This is just a copy paste. Now, in 2007, it was 100%. In 2008, it is 75%. Do you agree with this data?
Mm-hmm.
And what we have to do now is just cross multiply. So 75x is equals to 600 times 100 and x is equals to 600 times 100 over 75. This is exactly what we did right there. And also on the other side, you see 600 into 100 by 75. So this is just the thinking process. How do we perceive it? So the 25% was applicable on X, not on 600. And coming back to the wording of the question, in 2008, the new one is 600. It is a decrease of 25% on what? Not on 600. It was a decrease of 25% on the price in 2007. So decrease of 25% on 2007 would lead us to 600. That is a reverse percentage. A store is holding a sale in which every item is reduced by 10%. A jacket in this sale was sold for 108. Now, this 108 price is the selling price, what the customer is paying. This is the price after 10% discount. Original price would obviously be more than 108. Let's say the original was X, and on X, we decreased it by 10% and it became 108. Now we can cross multiply and solve for X, which comes out to be 120. So that was 120 initially, and then it dropped down to 108. If someone makes a mistake and applies 10% on 108, that would be 10.8 and give you an initial value of 118.8, which would not be true. Are you absorbing the concept?
Yes.
Let's try questions. 20% of an amount is 35. What is 100%?
175.
175, correct. 35% of an amount is 127. What is 100%?
362.9 or 363 to round it up.
Both are correct. Would depend on the demand of question. Three significant figure or one decimal place. Both are correct. So we'll choose three significant for now. So 363. Question 3. 245 is 12.5% of an amount. What is the total amount? Can you make the statement?
Yeah. So it's basically the reverse percentages still, right?
Yeah.
So it's 2x minus x, 87.5 over 100. X minus 87.5 over 100.
And what do you
So
get?
280?
Sorry,
280?
that cannot be. See, 245 is 12.5% of an amount. May I say that amount was X and 12.5% of that amount is 245. Or we can make those boxes. 12.5% is 245. So what will be 100%? We can make these boxes and cross multiply.
1,960.
1960. This is going to be this way. We have to absorb it, understand it naturally. See, if 12.5% is 245, the amount, the 100% should be more than that and a lot. 12.5 is like 1/8 of 100. So 245 times 8 gives me 1960. Question number 4. The table gives the sale price and percentage by which the prices was reduced for a number of item. Copy the table, then complete it by calculating the original prices. Okay. Sale price is 52. The customer is paying 52 and it is already been reduced 10%. Now we have this reduction value. All of these are reduction values. Can we just for once make a universal formula?
Sorry?
Can we just make a universal formula for once for all of these? So for example, let me say this is Y and that is 10% reduction. So after 10% reduction, the price is 52. That would actually mean that the original price, the sale price, is equal to original price times 100 minus this percentage, which is unknown, by 100. Do you agree? Let me fill in
So
the value.
sales
That would
price.
make more sense. Let's say 52 is equals to unknown price times 100 minus 10 over 100. That is 90 by 100 because we are getting a 10% discount.
Oh, yeah, yeah.
Yeah. So if I want to make it generic, I'm putting a square right here because this 10 is always changing. Sometimes it's 10%, sometimes it's 12%, sometimes it's 7%. So that 100 minus this percentage will give me the value. So this was the sale price. I'm multiplying this 100 on the other side. So sale price times 100 divided by 100 minus the percentage will give me the original value. So what am I doing? I'm finding the original value and multiplying sale price with this number all the time. 100 minus the percentage. For example, for the first one, it is 52 into 100 over 90 because 10% is reducing. So 52 into 100 divided by 90 is 57.7. So original price was 57.7, so on. 185, again the same. So 185 into 100 divided by 90. So what are we doing? We are multiplying every number with 100 and dividing with the remaining percentage. Multiplying every number with 100 dividing by remaining percentage. So I'm doing
So,
this 100 over 90. I'm doing this 100 over 90. I'm doing this 100 over 95. So 4700 times 100 divided by 95, and the original price would have been 4947.36, so on.
for 185, it should be 206 if we round it up. Or it can be 205.5.
Both are correct. Okay, try for 12.5.
13.4.
13.4 correct. Okay, let's see about question number 5. A shopkeeper marks up goods by 22% before selling them. The selling price of 10 items are given below. For each one, work out the cost price, the price before the markup. So is increase this price by 22%. What was the original price? Solve this first one first. 5A.
20.5.
20.5. Yes, 20.4918. 20.5. So you have perfectly absorbed the concept. Try this G part.
24.4.
24.4. Very good. Okay. Question 6. 7 students were absent from a class on Monday. This is 17.5% of the class. How many students are there in the class in total?
So the increase is by 7, basically. That's
Seven are
not what we
number of
talked about.
students.
7 are number of students. $40?
Correct. Uh, Look, we've discussed different methods. So whatever clicks is correct. 7 students were absent. This is 17.5. So I'm writing 7 ratio 17.5. So total should be 100 and simply cross multiply. So that is 700 divided by 17.5 gives me 40 straight away. So yes, 40 and B part would be
Oh, so just minus, okay. 33.
33. Question number 7. A hat shop is holding 10% sale. If Jack buys a hat for $18 in the sale, how much did the hat cost before the sale?
$20?
Correct. Very good. Nick is training a swimming race and reduces his weight by 5% over a 3-month period. If Nick now weighs 76 kgs, how much did he weigh before he started training?
$80?
Very good. 80 kgs. The water in a pond evaporates at a rate of 12% per week. If the pond now contains 185 liters of water, approximately how much water was in the pond a week ago?
$210.2.
Very good. Oh, very good. Perfect. Standard form. Okay. How do we write things in standard form? Now, the rule is whatever number we have, suppose 78600, whatever number we have, we will write the first digit that has to be a number other than 0, and then we will write the decimal, and then I'm writing the remaining number. I don't have to write these zeros after the decimal into 10 raised to power. I'm counting these. So when I consider these are 4 into 10 raised to power 4. This is standard form. For example, if we have 7, 8, 6, 1, 2, 3, 4, 5. So I'm writing 7.86 and counting all these 5, 6, 7. These are 7 numbers after the decimal into 10 raised to power 7. If I would have been given with the number 7.00786. So now what the rule was, write the digit first. It has to be non-zero. 0.86. Now you see, when I placed the first decimal, I actually reduced its value and gave it back. Now I'm writing this decimal here. I'm increasing its value. So I should bring it back by how much? 1, 2, 3. So into 10 raised to power -3. Does it make sense?
Mm-hmm.
So these are writing numbers in standard forms. Okay. Do you remember indices? When
Yeah.
bases are same, we add the powers. Let's quickly do a few examples before we go on to questions. For example, let's say I have 2 into 10 raised to power 3 multiplied with 3 into 10 raised to power 4. Now what's happening? I'm multiplying 2 into 3, which is 6, and basis same powers add into 10 raised to power 7. And if we have like 7 into 10 raised to power 3 multiplied with 3 into 10 raised to power 5, what will be the answer?
21 times 10 to the power 8.
Okay, 21 times 10 to the power 8. Mathematically, it is correct. But the demand of the question is to write as standard form. And what was the rule?
Uh,
Decimal after the first digit.
so 21 with 8 zeros afterwards. Oh, standard forms are 21.1 times 10 to the power 9.
Very good. So 2.1 times 10 raised to power 9. So this was multiplication. Now let's try division. 8 into 10 raised to the power 5 divided by 2 into 10 raised to the power 3.
So 4 times 10 to the power of 2.
Very good. 2 1 times, 2 4 times, 3 power goes, 2 remain. Now, multiplication and division is always easy and straightforward. Whenever we talk about addition and subtraction, suppose 2 into 10 raised to power 3 plus 3 into 10 raised to power 4. Either we make both of these powers same or we take out common. I'm making them same first. So if I write 20, sorry, this should be 0.2 into 10 raised to power 4. Is it fair? I decreased the value of 2 and increased it on the other side. And this is 3 into 10 raised to power 4. Now powers are same. So what can I write? 0.2 plus 3 into 10 raised to power 4. I took that as common. So this is 3.2 into 10 raised to power 4. Now I'm not changing this 2 part, but I'm interacting with the second half. So keeping it as it is, I'm writing that as 30 into 10 raised to power 3. Powers again same. So 2 plus 30 times 10 raised to power 3 makes it 32 times 10 raised to power 3. Still not in standard form. So 3.2 times 10 raised to power 4. Same answer. And the last one, all methods are acceptable. 2 into 10 raised to power 3 plus 3 into 10 raised to power 4. What if I just take out as much common as I could? 10 raised to power 3, 2 plus 3 into 10 raised to power 1. Is it mathematically correct?
Yeah. No, is it? Because it was only able to times the 3 by the 1, or is it just adding them
Your
together?
time. Take your time. I took out 10 raised to power 3 common from both of these.
Mhm. So yeah, it makes sense.
Okay, so 10 raised to power 3 is outside. This is 2 plus 30. So 10 raised to power 3 into 32. And now we can readjust 3.2 into 10 raised to power 4. So whichever path you take, we end up with same answers and all three are acceptable. Now look at this worked example. 3 2 times give me 6 and 5 plus 6 is 11. So 6 into 10 raised to the power 11. This was a single digit. 3 2 times was single digit or else we would adjust it. For example, in this B part, 2 8 times is 16 and powers add. So 10 raised to power 10. 7 plus 3 is 10. And adjusting this digit to make it standard form, converted it into 1.6 and increased the power by 1. Same goes with division. We only have to be careful when we are adding or subtracting these two numbers. Write each of the following numbers in standard form.
Three, what, which one do I start with? Yeah, okay.
Okay, sure, sure, sure.
3.8,
3.8
3.8 times 10 to the power of 2.
and to the power 2. Okay, try these three, C, D, and G. Should I zoom in?
Oh, yeah.
C, D, G.
So for C, I got 4.56 times 10 to the power of 10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very good.
For D, I got 6.54 times 10 to the power of 13.
Correct.
For G, I got 1.03 times 10.
Correct. Okay. Okay, rounding these numbers add as ordinary numbers. Try these two.
Two, two, four, with 5 zeros. So,
Correct.
so 9,900.
9,900 is correct. Okay. Try this K part without calculator.
10/3 into 2.
10 over 3. 10 by 3. No, we should not get 10 by 3. What is 17 plus 17?
17 is 34.
It's 34. So may I say this is 1 time and this is 2 time? That was
Mhm.
1.7 and 3.4. And we know that 1 by 2 is 0.5, right? Times when we deal with these two powers, 5 and 8, I'm left with 3 powers in the numerator. Now I can convert it into standard form, which would be 5.0 into 10 raised per 2. Clear?
Mhm.
Okay, let's try H part right above that. We have a decimal after 1, 1.5. All other numbers are without decimal.
Zero 0.3 times 10 to the power of 4.
Answer is correct. You have to change it into standard form.
Okay.
Three. Decimal should be after the first number. So 3.0, we've increased this. So we should decrease the other one to keep the number same. Okay. Hmm. Addition, subtraction, simplifying each of these. Try this. A part for addition and B part for subtraction.
So first one is 12 times 10 to the power of 7.
That's addition.
Cool.
This Sign right here.
Mm.
We have to be careful with addition and subtraction. Multiplication and division are easy.
So we add the 3 and the 4.
We can
We
only
don't.
add them if we have the same powers.
Okay. Oh, okay.
So either we make these powers same or we take them out as common.
3.4 times 10 to the power of 4.
3.4 times 10 raised to the power. Correct. Which method did you choose? Taking out common or converting the number?
Taking out common.
Good. B part.
3.7 times 10 to the power of 6.
Very good. Okay. Now, standard form for small numbers are those which start with decimals. For example, as we discussed, 0.000785. So it would be 7.85 times 10 raised to power. What would the power be?
So 78.5.
Power of 10. What should it be?
Oh, 4.
Be careful with this. This is -4. Why so?
Because it's going back, dividing it.
Yeah. When we move towards right, the power is negative, or in other words, just see this number was very small and I wrote 7. So if we are increasing this number from the digit side, we should decrease it back from the power side. And every other rule stays the same. Write each of the following numbers in standard form. 5.13, 4 into
It's
10 raised to power what?
4 times 10 to the power of -3.
-3. Now this is 5 into 10 raised to power what?
5. -5.
-5. Okay. Mm, try D part. 2D.
0
Is it
0.0088.
0.0088? Correct. And just look at question number 3. I see no difference other than the negative power. Like if we are multiplying or dividing or adding. Okay. Then this is just the use of calculator.
Sorry, could I quickly get water?
Yeah, sure.
Thank you.
Welcome. Okay, now estimation. That's a very small topic. For example, the question says that estimate the value of square root 37. So I know that is very close to 36. So I estimated square root 36, which is 6. And the examiner always requires us to show what we estimated. So for example, when we look at exercise, this question 1A, 26, 23.6, if I just write it as 24 and 6.3, write it as 6. This is 6 one time, 6 four times. So this is approximately equal to 4. When I punch in the exact values in calculator, I'm getting 3.74, which if I round off will get 4. So, and just look at this last number. If I write this as 4 cube times 2 raised to power 4, that is 64 into 16, and 64 into 16 is 1024. In this case, actually, the examiner is asking us to show the rounded value and it is leaving on us. In exam, he would tell you to round off till one significant or two significant numbers. So we can do that. Okay, so I'll share some practice questions regarding percentages and standard form.
Okay.
Anything you would like to ask, share?
No.
I'll share homework.